And then put x of t is equal to 2. Right? Because by the time the particle ends its path, the x is equal to 2. Now solve for t from here. So we get what? 1 goes over there, that's 3. 3 times 5 is 15. T to the power of 5 is, let's see here, 15. T is 15 to the root, 1/5 root, okay? 15 to the 1/5 power. What is that? Give that to me in 3 decimal places, so we could be a little more exact here. .719 seconds. So almost 2 seconds. So that's the total time that it took from there to there. Okay? Because now we're going to use that. So once you have the time, you put it over here. 1.719. This is the distance traveled in meters and seconds. That's going to give you the average speed. Point. Now we could go to 2 decimal places. 5.92 meters per second. Okay? So average speed 5.92 meters per second. Now the average velocity, right, is the displacement divided by time. Okay? The displacement, remember, is a vector that points from where you started to where you ended. So the displacement is going to be a little bit shorter than the distance, right? How do we get the displacement? Well, it's the final position minus the initial position, right? That's basically it. So 2i hat plus 8j hat minus negative 1i hat, negative 1j hat over the total time 1.719. And 2 minus 1 is 3. 8 minus 1 is 9. And you could divide 1.719 into each one. And then tell me what you get here. Let's go two sig figs here. 1.75 plus 5.24 j hat meters per second. Now, if I did the magnitude of this average v vector, it should come out smaller than 5.92, right? Because the displacement should be a little shorter than distance. So that's kind of one quick way to check your answer here. Do that. Square this, square that, add them, square root it. and you should get less than 5.92. Yeah, that's good. You see, you can tell from the picture even that the displacement is less than the distance. Okay, so that's the average velocity, and now the average acceleration, the problem was asking us. However, to do this, let's hold off on that. Average acceleration is v final minus v initial over t. But in order to be able to do that, we need to first know what is the final velocity, what is the initial velocity. So let's do part B first, because part B asked us what is the initial velocity, what is the final velocity, what is the initial acceleration, what is the final acceleration, and what is the initial speed, what is the final speed, all those stuff. So, okay. So part B here, what is the initial velocity? V initial. So that means we put t equals to 0. So on that side of the board there, we got the v function, and we put t equals to 0 into the v function there. And you put t equals to 0, you have 0 here for the x component, and you put t equals to 0 here. That's 0, so this is so the whole thing is 0. So the initial velocity is 0. The final velocity for t equals to 1.719 seconds, right? So you got to put 1.719 seconds into the v equation, t to the power fourth. So you got to put here 1.719 seconds, raise it to the power 4. 1.719 seconds, raise it to the power 4. Do all this. It's okay. So let me know here what you get. So you're going to get something to the power, something I hat plus something j hat. Okay. .73 104.99